Okay, in this problem I'm going to show you how to do a transportation maximization problem. To start off with, you have to have Solver installed on your computer. The way to tell if you have it installed on Excel, it's actually added into Excel, is to go to Data and look to the far right and see if right here if Solver, the far right, is listed. If you click on it, you should get the Solver parameter screen that looks like that. If you don't have it listed, you need to go to File, go all the way down to Options, and then go to Add-ins right at the left. And in the Inactive Applications add-ins, you'll see Solver. You need to click on Solver and then click on Go, and that will put the Solver add-in right here into the active add-ins. And then you would click on OK, and again go to Data to the far right and then check to make sure Solver is there. Okay, so in this problem we've got this right up here. You have two plants. Plant 1 can produce up to 44 million pounds of zinc, and plant 2 can produce up to 28 million pounds. At plant 1 it costs $21 to refine a pound of zinc, and at plant 2 the cost is $19 per pound. And then we sell to two countries, South Korea and France, and the shipping costs per pound are listed below. From plant 1 to South Korea is $2.40, from plant 1 to France is $2.65, and then these costs are from plant 2 to South Korea and France. So South Korea is willing to buy a maximum of 28 million pounds of zinc at $60 per pound, and France is willing to buy up to 48 million pounds of zinc at $62 per pound. So how many million pounds of zinc should each plant ship to each country to maximize profit, and what is the maximized profit? Okay, so the first thing you want to do is you want to look at the data. Plant 1 has these extracting costs from the word problem right there. The cost of shipping from plant 1 to South Korea is $2.40, plant 1 to France is $2.65. This is all just taken from the word problem. The selling price per pound for South Korea is $60, and to France it's $62. That's how much money you get for selling it to those countries. Then what we have to do is we have to put plant 1 and plant 2. We need to put numbers in here for how much should be made from plant 1 and shipped to South Korea, how much made in plant 1 and shipped to France, how much made in plant 2 and shipped to South Korea, and how much made in plant 2 and shipped to France. So these represent sums of the row. So this is just the sum of the row that will add up everything that the plant 1 can make, and that must be less than or equal to 44 million pounds, or whatever, 44, whatever the units are. Plant 2 is another sum function, so if you just take this formula here and copy it down, that must be less than 28. Everything that ships to South Korea and France must be less than or equal to 28. At the same time, we have a sum of this column right here. I just go equal sum of all of the South Korea amounts, and that must be less than or equal to 28 million. And all of the poundage shipped from plant 1 and plant 2 to France is the sum of this column, and that must be less than or equal to 48. Then at the very bottom we've got to do the objective function. So the objective function is to maximize profit, and the way we calculate the profit is these two are costs, the refining cost and the shipping cost, and then the revenue is the inflow. We need to take the revenue and then subtract the shipping cost and the refining cost. So to do that we need to use the sum product function. I'm going to go sum product, and I'm going to take the extracting cost, which is the 21 and the 19, and I want to multiply that by the shipping costs. Just a minute, hold on a second. So to get the refining cost, total refining cost, you have to do the sum product function twice. What you need to do is you take this, you go equal sign sum product, and you take plant 1 and plant 2 refining costs, or extracting refining costs, comma, I'll multiply that by the amount shipped to South Korea, plus the sum product function again, which is the amount of 21 and 19 costs multiplied by the France production quantities, and that gives you the refining costs. And then the shipping costs what you need to do is you need to take this sum product, and to get the shipping costs you would go right here. This is the cost per pound of shipping times the amount shipped by each of these plants and destinations. And then the revenue is equal to another sum product, which is going to be the 60 and the 62 multiplied by the total amount shipped into South Korea and France. Okay. Okay, and then the profit is just equal to the revenue minus the refining cost minus the shipping costs. So when you have all of those in there, and this right here, this column D18 is just the sum of all the plant 1 amounts, and this is the sum of all the plant 2 amounts, this is the sum of all the South Korea amounts, this is the sum of all the France amounts. So now what we can do is we can do the solution. We go to data, we go to solver. We want to optimize this figure right here by maximizing it, by changing these cells right here, and subject to these constraints. This is less than or equal to that. This is less than or equal to that. This figure here is less than or equal to that, the 28. And this is less than or equal to that. So we have 4 constraints, and that's how many we have here. 1, 2, 3, 4. We make sure this box is checked, and we go with the simplex method, and then click on solve. It found a solution, and what that says is we should ship 44 units from plant 1 to France, 24 units from plant 2 to South Korea, and 4 units from plant 2 to France. And that means our total profit will be 2,764, or 2.7 million. It's probably in millions. And that's how we solve the problem. If you want to see what it looks like this. You've got the different plants, and you've got where they have to ship, and then you have the different costs. These are just the shipping costs, but we also have to include, you know, other factors in addition to shipping, such as the cost of extracting and then the revenue also that you would get from it. But this is the general layout where you've got the plants and then you've got the different paths, each of which have different constraints, like we did in this problem. And that's how you go about solving this problem.